Okay, hello everyone. Welcome to the August 4th, 2021 meeting of sig-auth. Looks like we have a few items on the agenda. The first one is the certificates proposal update. Does somebody want to kick that off? Here, maybe.
Sorry, zoning out reading. Yes, we have fleshed out the proposal for issuing certificates, service account certificates directly to pods. Some people have already taken a look at it, especially Mo seemed to have taken a pretty thorough look at it. He had a lot of questions and seemed to want to take a different approach. So I think we need to discuss with him and see what his concerns are.
Cool. I guess what has been updated since the last time we looked at this?
Right now it's in an implementable, at least I think it's in an implementable state. Basically, the proposal is sort of, we create a new signer to back service account certificates, which are issued to pods. We provide a default implementation of the signer in Kube Controller Manager that just uses a key on that you provide via flag. Then using an annotation on your pod, you request injection of a certificate and key volume into your pod. And then Kubelet has a mechanism. So that is done by an emission controller. It injects a new projected volume type that holds a key and a certificate. Kubelet, in the process of mounting that volume, will generate a key, send a CSR to the signer, and then put the signed certificate into the volume, and it'll support auto rotation and renewal of the certificate. Each of these components is sort of like progressively disableable. So if you want, as a distribution operator, you want to sub in a different signer, you can disable the signer in Kube Controller Manager and provide your own. For example, if you want to integrate with some platform PKI or something like that, rather than using assert on disk. Sorry, I'm reading the question from David. Yes. So
like, for instance, if we decided, like, you know what, having a client certificate available for a service account sounds like a great idea, but no thank you to SPiffy. As I understand it, that would not meet your goals, or is that an approach you'd be interested in doing?
I would be disappointed because I think that SPiffy is the correct choice. But I think my primary goal is to make it so that a Kubernetes pod is never required to use a bearer token for any purpose.
So would you take an approach of, well, I could have a client certificate, and separately I could try to make a QAPI server support the SPiffy protocol?
Sure, but when I say I would be disappointed, I think that a lot of the value of providing this client certificate is not just for talking to Kube API server, although that's a good place to start. I think a huge amount of the value comes from, just like OIDC tokens that we issue to pods today, random other third parties can accept these certificates. And that's a lot easier to do if they don't have to build Kubernetes specific support. Just like we didn't roll our own JOT format, instead we chose OIDC. So third parties have a sort of uniform way to extract the sub claim from that OIDC token. SPiffy provides sort of the same profile for X509 certificates.
Now, I do think it's worth mentioning that a client certificate, as Kube describes it, has some unique qualities in how it encodes users and groups. I don't recall whether we specified exactly how extra is specified on these, but it seems like it would not be specific to a Cube implementation, right? You'd be able to take a CA bundle and verify these certificates anywhere, right?
Yes, but for example, if you wanted to authenticate to Stripe or Twilio, they would have to specifically build support for Kubernetes service account certificates. They would need to know our whatever we decide on our custom format for encoding namespace, user, or namespace and service account name, and then map that into their policy language. Whereas SPiffy sort of provides we'll call it some standard profile. Could be SPiffy, could be whatever else. That provides a common meeting point where third parties just have to know how to extract a relevant identity from the certificate that works for everybody.
Yeah, I guess I could go either way on this one.
I would really like to see it as either two separate things or say that as a prerequisite to champion and add support for SPiffy to the Cube API server before entertaining this proposal. Because right now, even the name is a little bit, right? Because it's talking about MTLS issuance, and we have an MTLS concept in Cube, and it is not talking about using that. It's talking about using something different. It's talking about using SPiffy. So I think trying to tackle those as step A to get to step B is fine with me. Or coming in with yep, let's make it actually do what it says on the tin and use the existing MTLS capabilities we have. I could also see that as useful. But trying to do both at the same time it seems like a lot to bite off. There's different ways to describe and classify that, but if you have independently valuable pieces, how about we go after those?
That makes sense.
The credential that we're also talking about maybe making better is also not always used to talk to Kubernetes API server. So yeah, I think I think maybe we can also consider service to service if that is one of the primary motivations.
And I would like to see support for legacy services in here. I don't want, I'm willing to go forward with this with a critical SPiffy extension, but I would prefer a non-critical SPiffy extension so that you can drop host names in there so that you can make this viable for legacy pieces of software. And I do think that the existing, SNI grants on certificates should be supported in some way or form.
Yeah, I guess did we figure out a heuristic for approving certificates that do have host or DNS SANs or host names? Is that proposed in this doc?
I think the way we handle that in this doc is that if you want to approve those certificates, you provide a custom, you ship your own signer, and then you can use an annotation to request that kubelet send the request to your custom signer.
Okay.
And that behavior being implementation specific is not unreasonable. So long as there is sort of so long as we are clear about what is and isn't implementation specific on the grants that are generated. To some extent, being not specifying what these TLS certificates actually look like, not specifying how you extract a service account from them, not specifying what what is actually said, what is signed, is an advantage because it allows you to be flexible and to say it's implementation specific to, so that providers can provide grants that match what they are willing to sign. On-premises Kubernetes has a very different set of expectations than Kubernetes that is hosted by one of the major cloud providers.
I don't know that I agree that having a standard kube signer, which can sign a certificate that either looks like A or looks like B, and can be verified like A or be verified like B.
That is not what I'm proposing. What I'm saying is that we should make it clear that the standard kube signer has this format, but this is pluggable, and the actual certificate that you get may not be this if it's signed by some other signer.
Right. So I guess I'm confused then about what you're saying, because if I create one that says I want to have the Kubernetes IO service account signer, and there is one version that creates SPiffy X509, I don't know how to pronounce it, SVIDs, and another version that says, no, I don't create that. Then I'm going to be verifying, when I try to consume these, I'm going to be trying to verify them in different ways. And I don't see how I could consistently use the certificate that I get back as being signed. It doesn't. The
remote party does not have any knowledge of the Kubernetes.io service account signer. It sees a TLS client certificate. I do agree. Maybe the answer is that the service controller is that there are multiple different signers, that there is a Kubernetes automatically add service, or there is a Kubernetes controller that will automatically add a that based on the annotation automatically adds a TLS secret volume and requests a CSR for some named signer, where Kubernetes.io/service account is the default signer, but that you can paste in your own implementation specific signer. Does that make sense then?
I think the thinking, at least what I was thinking, is if you choose to make use of this knob, this annotation that says redirect me to, I don't want this to come from the service account signer, I want this to come from my custom signer, then you have like voided the warranty, and now you have to make sure that the certificates you're getting, like it's your problem to make sure that they're going to be trusted for whoever you present them to.
That makes sense to me.
I'm open to the idea of, moving first to have a smaller cap that says, let's teach Kube API Server how to understand SPiffy certificates, for example. I'm a little worried that it's like an ecosystem bootstrapping problem, right? Like there's not.
Yeah. Until there's some reason to have SPiffy support in the Kube API server until it's being used, why add it? Until you've got these TLS certificates signed with SPiffy, until you have that support, why sign these TLS certificates? Why make them available?
Well, so I mean, we would 100% use that support in GKE.
Yeah.
We have a lot of SPiffy stuff.
And I'd like to see EKS use their own implementation. I'd like to see on-prem have all of this. I'd like to replace the bits that I have hacked together with something that is standard.
Maybe it would help to sort of, I think there are like 3 mechanisms being discussed in this proposal. One is the SPiffy aspects, like the API server recognizing SPiffy. One is the projected volume mechanism which sort of takes care of key delivery and interaction with the CSR stuff. And then one is this like specific signer that we're discussing. And I think we're sort of getting like all three tangled together. And some people are like hearing one of those mechanisms and thinking, oh, I could use that for X, Y, and Z. That sounds cool. I don't know about those other two. Maybe it would help to like describe the mechanisms. And then I think what Mo was asking about was like for each of those mechanisms, like the signer and the API server authentication bit and the projected volume bit. Like there are things that would let you do that out of tree, like with a CSI driver or with an out of tree controller. It would just be helpful to kind of enumerate, like, here are the mechanisms this is proposing. Here's what could do this today, like out of tree, either as a proof of concept or as an add-on to, like, I think we want to try building these things like on top of Cube before we build them into Cube and commit Cube to a particular direction, if possible. And then if there are some of those mechanisms that you can't effectively do out of tree, like that's useful to know. And that might sort of help untangle like the use cases and untangle like interest in particular aspects or get ordering correct. Because I think there are some things, like as you were talking, like being able for a pod to say like, please inject like a certificate and a key for this signer. That seems like a really generally useful thing. And like, if I have a delivery mechanism for my signer and I'm issuing like in cluster serving certs or whatever, like that seems like you could use that for a lot of different mechanisms, not just this MTLS one. And so by teasing those apart, it might help sort of get ordering or consensus or identify additional use cases and clarify like which ones we should look at first or maybe build in first.
I can take a look at doing that. Briefly, the answer is each one of these pieces can be done out of tree. And we have, in fact, done that.
Yeah, all of these bits have been built before. Not necessarily in quite the same way, but they have all been built before.
Is the pod authentication to the API server using a SPiffy certificate? Is that possible?
Yes.
That seems hard
using
to
a front proxy.
Not using a SPiffy certificate, but using a certificate or using a proxy in front of it. Yeah.
So we've investigated. So this I misspoke. At least internally, for the project I'm thinking about, we have not done we've not actually implemented the Cube API server piece, understanding SPiffy, but we have a design for doing it using Envoy in front.
So do we have a reasonable enough AI to try to like figure out which come up with the priority among these three components and maybe propose them independently as a smaller chunk that we can debate and try to get in, just to turn this into something incremental?
I came with a set of smaller bits at one point, and I don't know why that. I don't really remember why that also was tabled.
I apologize if I was part of tabling that. I don't actually remember these things showing up before. I remember like externalizing TLS handshakes and things like that. The one, and I can't remember if it was talked about in conjunction with this proposal or separately, but the idea of being able to inject certificates to pods for serving that all of our API server to pod mechanisms pay attention to, like emission webhooks and conversion webhooks and various things like that. Like having a signer that lets you get certificates for that. It seems like it would simplify a lot of people's lives. So I'm interested in the projected CSR mechanism specifically.
Okay.
Well, I mean, that's not so disentangleable, right? Because in order for Cube API server to authenticate to those things, we have to decide on a certificate format.
Yeah.
And we have to.
We don't have to decide on one certificate format. We can progressively add and remove features from it as beta, right? We can decide, we can build something that uses the existing format and decide if it needs SPiffy.
Right, and that's why I think breaking these apart sort of gets some of the value sooner, like being able to inject a certificate for a signer and defining how that interaction works. Like the pod spec requests it, says what signer it wants, and then in the request, the kubelet makes on its behalf, it encodes information about the pod that it came from. So it's requested by the kubelet with pod ID, namespace, UID information. Like having that piece defined lets you get value even if you haven't settled on building SPiffy in or not, or having like an auto identity certificate be SPiffy or not.
Okay, I can break that out to a separate cap. I believe that is fully specified right now in this in this doc. And now the answer right now is the CSR is a SPiffy certificate with some extra what are they called? OIDs with extra information, but then we note that the signer is free to totally disregard the CSR and just extract information from it and issue its whatever certificate it likes.
That aspect seems a little bit weird to me in terms of like, how do I use this? But having a client certificate, like one that could be accepted today by the Cube API server or terminated by anybody who understood like that same sort of pattern, that seems like it'd be fine to me.
The problem is what information, what claims do we encode into that? A client certificate that can be interpreted by the Cube API server is very simple. It just has in the common name the service account identifier.
Does that seem like a good
not
place?
Even a service account identifier, right? Just an arbitrary string that will be passed to the authorization layer.
Sure, but what we would do for this circumstance would be the service account would be matching the format and would be interpreted as the system service accounts namespace service account, right? It just so happens to match. It is an arbitrary string, but it is also an arbitrary string that is well formatted and understood by the Cube API server.
Just as a thought experiment for like small individual pieces that would probably not face much objection, having a client certificate for a service account seems like a very good idea.
I agree.
Yeah, and it at least helps us focus the discussion a little bit. So yeah, I do think that would be helpful, and we can at least start to move the less controversial bits in slowly, or decide not to. So
All right. That sounds good.
Awesome.
Right.
Yeah, well, I'm sure we will discuss this next sig-auth meeting, but yeah, thanks for bearing with us, both of you. Cool. I actually missed an announcement. Quota, Jordan, what's the?
I didn't have the announcement, but the 1.22.0 release is getting tagged like as we speak. So I would expect code thaw, I don't know, later today, tonight, tomorrow, something like that.
Awesome. Thank you. All right, Tim, you are up. Common approaches for delegated pod mission and policy.
Hey, so this is an issue we filed a few years ago when we started thinking about future of pod security policy. We have a bunch of different policy-like things in Kubernetes, and they all apply to policy in pretty different ways. That's kind of what's summarized in the top section there. And then in the second half of this issue, it sort of describes what some of those different approaches are. So I wanted to re-raise this because with the addition of pod security admission, we're adding another policy type object, going to get rid of pod security policy. And pod security admission is applied at the namespace level. So it's more momentum towards this namespace level policy. So this is not a super actionable issue. I think the question here is kind of like, do we want to declare essentially that namespace level policy is sort of the way forward and can consider this issue closed? Or is there more, do we feel like there's more discussion and follow-up that still needs to happen here? I'm not necessarily looking to have that discussion or make that decision now, but I sort of wanted to get this back on people's radar.
My feeling is that of the options listed, applying policy to the pod service account and to the requester should probably be struck out as generally good options. We went into this in a lot of detail with the pod security policy stuff like that. It just is confusing and doesn't work well with how Kubernetes objects work with controllers and stuff. Applying at the namespace level seems to be what things are converging on and is pretty reasonable to understand. I know there's been efforts on the delegated auth stuff or investigations, but that hasn't, most of them seem to have stalled out on the like convince all API actors to make changes to propagate delegated things. So I'm not sure I see that really happening realistically.
So a comment about using service accounts versus namespaces. So namespace level configuration is nice in the sense that everything inside the namespace is always consistent, but service account level permissions are nice because a user can have the power to delegate his own permissions to a service account, but probably does not have the power to modify a namespace and say, this namespace has this power, right? Using our default permissions, you don't get namespace.
I know you know how to
do it.
You know how to
Role binding permissions.
Yeah, and I do want to make the distinction that some of these are kind of runtime enforcement policies, and then some of these are more like API admission, which do have kind of fairly different semantics. Like you can have you can have two service accounts or two pods in namespace with different pod security context. But I think to have two sets of administrators where one set can run as group A and other set can run as group B is much more challenging with kind of what we provide as far as toggles. And I think maybe the second makes a lot of sense for namespace level, just to align kind of administrative access up. And I'm not sure whether the same is true for something like network policy, where it actually might make sense to generally say that, you know, we need finer granularity of network policy than the namespace level. But I don't know.
Yeah, I definitely agree with that. That it's worth separating out the sort of control plane policies from the data plane policies.
Yeah.
If we did choose namespace level instead of service account level, how would a namespace admin be able to delegate authority he may have to a service account or to that namespace, right? Right.
So you're talking about like granting a service account permission to create pods, but wanting to like subdivide what types of pods that service account could create. Is that right?
I'm thinking more in terms of like, if I want to have this power inside of a namespace, the only person who can grant a power inside of a namespace today is someone who can label it, right? But if I want to, if power is granted to a service account, anyone with admin privileges inside of the namespace can delegate authority. So you could say, like, this person can delegate authority for whatever it is I grant him power to do, since RBAC's non-escalating, right? So you may not have namespace editing privileges, but maybe you have the power to, oh, what's something on this list?
Create limit range.
I mean, it seems like the question is primarily whether you want to subdivide a namespace or not. Because if you delegate access to a service account, the service account can do anything allowed in the namespace. So maybe I'm misunderstanding what you're saying, David, about delegation to a service account. Are you wanting to say like the namespace allows this quota or permission or privilege or whatever? I want to give a service account ability to do a subset of that in the namespace.
There is some aspect of that, but I'm also thinking about in terms of like mechanically, how do I delegate my powers as a namespace admin who can running privileged pods doesn't make sense, but like a namespace admin who can do a thing. I can create a role binding for permission that I have in a namespace or in the cluster. I can't do that if I don't have namespace labeling permissions. I don't have a way to do that externally, right? And if you grant someone namespace labeling permissions, now they have the ability to modify any permission at all in that namespace. And maybe I only wanted them to be able to modify, I don't know how network policy works. I don't know if it's a realistic example, but maybe I only want them to modify network policy, or I only want them to be able to modify pod security policy, or I only want them to be able to modify a node selector. But by granting namespace labeling capabilities, I can't distinguish which of those.
Yeah, so for like network policies, those are included in the edit and admin roles. So you can create network policies that constrain network visibility that are effective inside your namespace. Image policy is like hard coded into the API server config. Resource quota is a namespace object, but it's not granted to admins by default. It could be added. I think it tends to be sort of domain specific, whether there's an object inside the namespace that controls the configuration of it and how and whether it allows subdividing. So like resource quota can scope quota to particular types of pods or particular resources. But all of them have the thing they have in common. So network policy, image, I don't know about image policy, the resource quota, limit ranger, the thing they have in common is that they are namespace scoped. Like you don't have resource quota that applies to half of a namespace and not the other half. And so if this is asking like, what's the approach? I think the approach is namespace scoped. David's question about how do you express that is a reasonable one. And so that might be an argument in favor of a namespace scoped object if it's something you expect someone who's constrained to that namespace to be delegating. So the three approaches I see are sort of API server config, or namespace annotations labeling, or objects inside namespaces. So that could be worth clarifying and sort of categorizing the existing things in those terms, and saying the things that have objects that live inside a namespace, you can choose to let a namespace user create or edit or update.
Yeah, that makes sense to me. Is there a better place to kind of spell out these thoughts and decisions than just recording it on this issue and closing it out?
I'm going to search the website for developer, like the community repo. I would probably guess community repo, since that's more development facing. I guess it depends. Do we want this to be focused on Kubernetes developers or on like anyone writing any policy thing for Kubernetes?
Right.
I think that there are going to be questions, or actually are questions about like, hey, I want to have this action taken by the resource owner. And you go back and say like, no, there isn't an owner inside of a namespace. You have all the editors and all editors are equal. I get that sort of a question quite a bit. I got one today, actually.
So maybe, yeah, I'm not sure where it would live. Maybe a new topic, sort of under controlling access. I think we touch on the idea that there's not like a creator, but spelling that out and sort of talking about the implications as it touches to this. I don't really see a great place under the website for a topic like this. You could cross-link it from everywhere. Like, it would show up in admission, dynamic admission, authorization, authentication. I don't know.
Probably wherever RBAC currently is. It sort of belongs in the how do you create proper RBAC rules.
There's a policy folder that talks about limit ranges and pod security policy and resource quotas. That maybe in the overview for that would be a good place to describe this, and then link to it from the authentication authorization sections, maybe.
Sounds good. I can take that as an action item to get some of that documented.
I'll put that in the minutes as well because the chat goes away.
Awesome, thank you, Tim. All right, so final item. Micah, do you want to take it from here?
Yep. Yeah, so after our last meeting, I just went ahead and tried bumping the AWS CLI like client auth API version, which if your existing kube config specifies the client authentication v1 alpha 1 spec, and the tool that returns a JSON blob has the v1 beta 1 spec, things break.
Does the tool not have a way to detect that it was called that way?
No. I mean, the tool would have to
take an arg to say, like, what version?
Yeah, right. I mean, so I think there's kind of two ways to do it. One is to, I think it's going to be really hard, honestly, without Kube API Kube client Go or whatever, giving more information about the request, like what's the expected API response type. And or what kubeconfig is being read in context, because as a tool returning a token, or in this case a token, I don't know what API version I'm being called with.
I thought that client Go sent, like, that doesn't it encode information about the token request in an environment variable? I thought it did.
If it does, that'd be awesome. I just missed that.
Okay. If I thought it did, I know it does in newer versions, because we actually had useful information to pass, like, is this interactive or not? It's possible that in older versions that was not passed or was passed inconsistently. And my recommendation would be, if you have an existing plugin and you want to change the version it replies in, like, make that an arg to your plugin. And so old kubeconfigs that were already calling your plugin, it will continue returning the same version. And newer versions, when you configure it to say, like, v1 beta 1 or v1, like, say, please speak in v1. But I will circle back and find the end bar. And it's possible that that was added in some Cube or Client Go versions more recently.
Okay, yeah, that I just wasn't aware that that was there, but that would be great to get, because I'd love to update to that, but also not break people. I mean, updating the kube config fixes it, but like, that's not obvious that that's the solution.
No, it's reasonable to want your plugin to be able to continue working with existing kube configs.
Awesome. API versions. All right. Yeah. Let us know if that is not true. Cool. Is there anything else that anybody wanted to discuss today, or should we hop into test flakes? Cool. So loading 0 megabytes. Looks like the test flake cluster.
There is too much data for Chrome to parse. You're going to want to use Firefox, apparently.
All right. Well, that is good to know for the next meeting, but I am currently do not have Firefox installed. So I will cut to TestGrid. What's the best view of this stuff? TestGrid as well is unable to load outside of Firefox.
Yeah, for the CSI driver, we actually grouped it into a couple of categories. And I think like mostly we are focusing only on the post submit, the release signal, and the periodic. And they've mostly been passing, and we recently migrated some of the providers like GCP to use workload identity and all that. So hopefully in the next couple of weeks, we'll see more green on it.
Awesome. And okay, so GCE finally started working. And looks generally still pretty happy, which is kind of the status last time. Cool. So I guess we'll skip CI flakes, the cluster, this meeting, and grab it next time. Cool. So looks like we are out of topics for today. There's nothing else. Let's reconvene in 2 weeks. Thanks, everyone.